Yeah, so going over the containers in the cloud. So typically, yeah, I even like these explanations. So this explanation, they also do it like a containerized, just like normal containers that we have, or normal containers that we see today are carrying. And you can see that those containers, or let's say someone who even uses those containers as a shop, they have like an extracted, they're like a extracted section of a shop, and it can even be used as a lift and shift. You can take it anywhere, anything you want to use in this shop, you can also use it there. So someone is asking for the link to be called on the group. So please, someone should share it to the person. So, and under containers, there are a whole lot of things that we can do on containers, and containers typically fall under infrastructure as a service because they allow us to share compute resources with other developers using virtual machines to virtualize our hardware. So with IaaS, infrastructure as a service that we've defined before, it's more of like sharing compute resources using VMs by virtualizing hardware using virtual machine. And going over to how that interrelates with containers. Containers helps us to create independent workload scalability, and it also provides an operating system and hardware abstraction layer. So typically, it's different from a virtual machine in the sense that it is independent and it helps to isolate workloads. So and they are also lightweight in the sense that you may think that containers are heavy, but you cannot compare the size of a container to the size of a house. So you typically cannot compare that. So containers are light, they are lightweight compared to carrying. It's not even possible to carry a house. So compared to virtual machines, and that is why containers they are something that we can easily use to spin up a particular thing or just to launch a particular application in real time. So the idea of container is to give independent scalability of workload in platform as a service and an abstraction layer to the operating system and hardware that's in infrastructure as a service. And containers are also like configurable. They are a configurable system because you can customize installation, can customize configuration and your building. And they are also large, slow, and costly. So typically, as the demand for your application increases, you have to copy an entire virtual machines and boost the guest operating system for each instance of your app, which can be very slow and costly. But with container, you more of just isolate the processes between different ones. So with a container, you would more often than not just run the operating system needed for the particular application or the other particular software they are using in that container, and in another container also you'd also run the operating system that it's also needed for that one. So it is not something that because I want to change something I have to change everything, or because I just need a tweak in a little bit of a code or a little bit of a configuration and I have to do for all the applications that are running in a virtual machine if it's a case of a virtual machine. And there are various platforms that brings about the containerized effects in Google Cloud. So with App Engine, you get access to programming services. So you only need to write your code in self-contained workloads that uses these services and include any dependent library. So typically with App Engine, you get access to programming services to write your code. So it's abstracts away the process of maybe doing some installations that may not be necessary when you are using a typical virtual machines. But with App Engine, you just need to just throw your code in and your code get run. So it is seamless, independence, and rapid scaling. You can easily scale up your workloads, scale down your workloads, and no fine tuning the architecture to save cost. So there's no case of I want to save cost, I have to reduce the memory that I'm using, I have to reduce this and that. So since it is more of like a scale as you go service, it is majorly what you are consuming that you are using at that particular time, and you're not just using excess. So, and understanding a container also, a container is an invisible box around your code and its dependencies. It has limited access to its own partition of the file system and hardware. So it's typically just limited to what you are doing at that particular time, and only requires a few system calls to create and start as quickly as a process. And it also needs a operating system kernel that supports containers and a container runtime on each host. So everything is abstracted. With a container, it comes with its own kernel, it comes with its own runtime, and they also have their own respective hosts. And it can scale like a platform as a service, but also give near time. It also give nearly the same flexibility as infrastructure as a service. So when we were talking about platform as a service, then we said something like Gmail, something like Google Sheets. So it can scale as much as that, as much as your Gmail can scale. When Gmail typically have like maybe a 30 gigabyte storage, but I know you can pay for more if you reach that limit. So you have the ability to scale as much as that, and maybe to abstract away running a whole lot of configuration, but it can also give you the flexibility of an infrastructure as a service, because with infrastructure as a service, you can build what you like. So Gmail is built for us, for everyone already. There's a limit to what you can change in Gmail that is not predefined by Google. But with containers, you also have the flexibility to create or to create a lot of things and to just make it suit your own application, just as you would have in an infrastructure as a service. So that's an overview of what container is here, and going over an example. So let's say you want to scale a web server in seconds. So with containers, you can do this in seconds by typically just deploy dozens or hundred of them, depending on the size of your workload on a single host. So this, instead of having everything here with containers, you can just abstract everything in hundred of places and deploy them on a single host. So scaling one container, running the whole application, scaling one container, running the whole application on a single host. So this is just a simple example of scaling one container, running the whole application on a single host. And okay. So likewise, if you want to build your application using a lot of containers, each performing their own functions like a microservice, there's also an idea of microservice in containers. We'll get to that in a bit. So they are modular, they are easily deployable, and they can also scale independently across different hosts. So all these things, they're just different versions of containers across different hosts. So to just understand containers clearly, or to understand what containers really mean, I'd say we can we can take a look at Kubernetes.io. So Kubernetes.io, it's a website that talks about containers, and I think their documentation is quite very easy to understand, because I see that especially for someone who have not even used Docker before, or a Docker image, or just having a Docker, launching it on your system and using it, you may not really like understand the benefit of having a container, or how powerful a container can help you in your infrastructure. So you all can take a look at Kubernetes.io website and just read about, maybe they are getting started with Kubernetes on the platform, so you can have more granular knowledge of what container is. So, and the application on cloud that helps us to scale containerized application is called Kubernetes. And Kubernetes was created by Google, but it was eventually open sourced. But there's a managed deployment of Kubernetes on Google Cloud, which is the GKE, the Google Kubernetes Engine. And it's saves times and efforts. So when you use GKE, it helps you save times and efforts when scaling application and workloads. So Kubernetes can be bootstrapped using the GKE. So GKE is just a managed deployment of Kubernetes on Google Cloud. So what is Kubernetes? Um, Kubernetes is an open source platform for managing containerized workload and services. So those containerized workloads, we use Kubernetes to manage them. And it also makes it very easy to orchestrate many containers on many hosts. You can also scale them as microservices and deploy rollouts and rollback. So one thing I can use as an example in this case is, let's say in a case of an application, some applications can deploy multiple versions of their application, and typically they only have the ability to do this efficiently and maybe cost effectively when they use a containerized application. So an application can maybe just roll out 20% of traffic to a new version of the application on a different container and keep the remaining user, that's the remaining 80%, on the previous version, and get feedback from those 20% who are like having the first access to that particular website, that particular updates. And when they see that, oh, it's good to go, then they can roll out the deployment to 100% of the traffic. So if you want to do that in a virtual machine, it's going to cost a whole lot, because you have to create two different virtual machines. You have to have something like that would serve as a load balancer, a whole lot of infrastructure that you do. Even if you're not now using a cloud application, then you have to have multiple servers, one for the new app, one for the other app. But with Kubernetes, since workloads are isolated from one another, you can just deploy multiple versions of your application and route the traffic as you want to those different services or those different workloads. So Kubernetes is also a set of APIs to deploy containers on a set of nodes called a cluster. And it's divided into a set of primary components that run as the control plane and a set of nodes that run containers. And you can describe a set of applications and how they should interact with each other, and Kubernetes figure out how to make that happen. So when you just describe a set of application and how you want them to interact with one another, if you want, with the previous explanation, if you want 20% traffic to go to this, 80% traffic to go to this, so Kubernetes figures out how to make that happen, and you necessarily no need to worry about how do you want to implement, or if just all you want to do. And deploying containers, you deploy containers on nodes by using a wrapper around one or more containers. And we also have a pod. We have a pod and we have nodes. We'll get to the explanation of each of them one by one. But just know that when you're deploying containers on nodes by using a wrapper around one or more containers, it is what's defined a pod. And a pod is the smallest unit of Kubernetes that you create or you deploy. So the smallest unit of Kubernetes that you are creating, it's a pod. There's a pod here, there's a pod here, there's a pod here, and everything are just in a cluster. So a cluster also consists of multiple nodes. You can have node 1, node 2, node 3, and each of them is in a cluster. But in each node, you also have a pod in each node. So a pod is the smallest unit in Kubernetes that you can create or deploy. I'm going further. So, and it's a pod represents a running process on your cluster as either a component of the application or the entire app. So the pod can serve as a component of the app, or it can also serve as the entire application itself. And more often than not, you only have one container per pod. But if you have multiple containers with hard dependency, you can package them into a single pod. But just typically, you have one container per pod. So going further, and they can also share networking and storage resources between them. So each of these containers, yeah, they can share networkings or they can share resources so far as they are in the same pod. So it may just be one storage, one backend service or one database that serves that serves all the application in different that serve both application in different containers in a pod. So there's ability to share networking and share storage resources. And also The pod provides a unique network IP and a set of ports for your containers and configurable options that govern how your containers should run. So typically, everything you want to set in regards to a container, how you can connect to that particular container, the ports that are available for your connections, all these are governed by the pod that houses those containers. And with the when you're dealing with containers or when you're dealing with Kubernetes, so you use the kubelt run command. So the kubelt run command is used to start a deployment with a container inside a pod. So when on GCP, there are two different things. When you're dealing directly with the containers, you use the kubelt command. But when you're just dealing with GKE services in general, there's there's a code called the gcloud. So you use the gcloud command then. But when you're dealing directly with Kubernetes services in GKE, you use the kubelt command. If we run through the lab, we should see where we are going to use this along the way. And a deployment represents a group of replicas of the same pod, and they typically keep your pod running even when the nodes they run on fail. So there's a deployment, and the deployment, it's like a group of replicas. So replica means when I create multiple versions of something, so that if one of them fail, the other one can still keep it alive. So a deployment could represent a component of an application or even the entire app, just like we said about pod. So the command also is kubelt get pod, and that would show you the pods running in the container service or in the container cluster. So likewise, Kubernetes creates a service with a fixed IP address for your pods. So each and every of those pods has a fixed IP address and a controller. So each of all those pods also has a controller, and the controller is like the head of the activities that go on in that particular pod. So here is an example. I need to attach an external load balancer with a public IP address so that services so that outside the cluster can also access it. So something like that, it's the controller that would assign a particular pod or a particular node to perform a specific function. And then in GKE, there's something we call load balancer. So the load balancer is created as a network load balancer. We should get to what load balancer does. So any client that creates or that reaches an IP addresses will be routed to the pod behind the service. So a service is an abstraction which defines a logical set of pods and a policy by which to address them. So at the back of a pod, there's like a service, and the service defines a logical set of pods and the policies that govern or the policies that determine who get access to those particular pods. And as deployments create and deploy pods will be assigned their own IP addresses. So the deployment can create more pods or can destroy pods that are not healthy again. And those new pods would also get their IP addresses, but those addresses don't remain stable over time. So sometimes if the pod is a normal LD, then you can destroy those pods and create a new pod and change the IP address. So a service group is a set of pods, and it provides a stable endpoint or a fixed IP address for them. But for the pods in a service group, they more often than not have a fixed IP address or a stable endpoint that you can access them from. So an example, if you create a set of pods called front end and back end and put them behind their own service. So the back end pod might change, but the front end pods are not aware of this. They simply refer to the back end service. So because pods now are now in a service, so even if the IP address of a pod in a particular service change, it still takes the normal connection because those pods in those service we only know them by one name, and the other connection talking to it also know it by one name. So and it's not possible for the name of the service to change, but the IP address of those pods can change. But since they are still under the same service, the new pods they also get called when needed. And to scale a deployment, so you can run the kubelt scale command to scale your deployment of Kubernetes. Maybe if you need more CPU utilization, or you just need more complete memory, you can scale your pods. So this is a code about containers showing the configurations of the container. So these are the, so it's like an engine X web server here. So the specification of the container, it has 3 replicas. The templates, these are the templates. So you don't necessarily need to worry a whole lot about all these things. So this is the container image, this is the container ports. And as we go on, we'll see if we'll touch some of them. So looking at the replicas, so you can check your deployment to make sure the proper number of replicas is running by using the kubelt get deployment or the kubelt describe. So when you run these codes, this one or this, you can get the amount of replicas that are running or some of the configurations that are running on your containers. So to run 5 replicas instead of 3, all you do is just update the deployment config file and run the kubelt apply. So when you show the kubelt describe, it's going to show you the configuration files, and you can easily just change the amount of replicas you want, or even change the container image to talk to another thing. You can still reach your endpoint as before using the kubelt get service to get the external IP address of the service, and you can also reach the public IP address from an external client also. So going over this the last question is, what happens when you want to update a new version of your app? Okay, so when you typically want to update a new version of your app, that means you want to update your containers to get new code in front of your users. But rolling out all these changes at once would be risky. So this is just going back to what I explained before. So in this case, you can use the kubelt rollout or change your deployment configuration file and then apply the changes using kubelt apply. So new pods will then be created according to your new update strategy. So, and here is an example of the configuration that creates a new version of pods individually and wait for new pods to become available before destroying the old pods. So those old pods that holds out those previous version of the application would typically wait for the new one to get created before they now get deprecated, or they get out of service. And so now they said we have a basic understanding of containers and Kubernetes. So I see that there may still be some blurry parts, but this is an high level overview of what Kubernetes means. And you can take a look at the Kubernetes.io that I mentioned. Let me see if I can bring them out here. Kubernetes.io. Oh. Yeah, so when you take a look at these websites, maybe you can go to the training or documentation. So I think it is done in a way whereby it's easy to understand to a great extent, and you can go over the getting started or go over the tutorials to see how Kubernetes just work on a high level. I'm going back to this. So let's talk about the Kubernetes engine or the GKE specific to the Google Cloud platform, and see how the GKE works. So like we said before, GKE is a managed Kubernetes service, and the GKE environment consists of multiple machines, specifically compute engine instances grouped together to form a cluster. And so in the cluster, we have multiple virtual machines, and each of them, they are grouped together to form a Kubernetes cluster. And by using the Google Cloud Console or the Google Cloud command line that is provided by the Cloud Software Development Kits, you can just run the gcloud command to maybe create your Kubernetes cluster, or you can just use the console to create a Kubernetes cluster. And GKE clusters can be customized, and they support different machine types, number of nodes, and network settings. So depending on what you want, you can choose what configuration suits best for what you are doing at that particular time in Kubernetes. And Kubernetes provides the mechanism through which you interact with your cluster. So since it's a managed service, it all saves you the stress of a lot of mechanism or a lot of configurations. It does that for you automatically. So with Kubernetes, you can deploy and manage your application, you can perform administrative tasks, you can set policies, and you can also monitor the health of your workload and see if a pod needs to get replaced. Is it going to replace them for you automatically? And we have also some advanced cluster management like a load balancing for compute engine. So load balancing typically means sharing load among different compute engine instances. If a load is quite occupied, it's not going to keep pushing traffic to that particular virtual machine since it's already occupied with a lot of load or a lot of traffic. And when that happens, it can even lead to slow service or slow response. It can easily just route those traffic to some other virtual machines that are free. So the next one is node pool to designate subnets of nodes within a cluster. So there's a node pool, and it's from those node pools that nodes or subnet of nodes are designated within a cluster. So automatic scaling of your cluster nodes instance counts. There's also upgrades for your cluster node software. So since you are using a managed platform, it's going to do all those scaling, upgrading, installing maybe security patches. It's going to do those for you automatically, and you don't need to do those things on your own. So there's also a node auto repair to maintain the node health and its availability. And it also comes with logging and monitoring with Google Cloud Operation Suite. So logging is just to see logging typically helps you to know who has done something. So let's say when I spin up a cluster now, it's going to on the login, it's going to say, oh, this particular email that is linked to this Google Cloud account was the one who created this cluster. So that's what logging typically helps you to do. It helps you know who have done a particular thing. But monitoring helps you to secure, it must like help you to have an high level overview of how much compute you're consuming, how much of a particular thing is running, and when you're going, maybe you're going over the bill you set, or when you're still within your bill. So with monitoring, you can create alerts, you can create dashboards that would give you an eye overview of how is my resources going, or how am I consuming a lot of resources, how is my clusters, what is their health rate, or how healthy are they. So all these things are some of the things that monitoring can give us. But logging is just to know who did something and like have a path to know who configured each and every service, or who did a particular thing in Google Cloud. So that's for logging, and you can start up your Kubernetes on a cluster in GKE, and all you just need to do is a gcloud container cluster create. So this gcloud is just the generic gcloud command, and when you are dealing with container, you have the container. So this is clusters. You wanted to create a Kubernetes cluster, and you click create, and this will be the name of your cluster. So if I run this code, it's going to create a cluster name K1. If I change this name, it's also going to create the new name of the cluster that I'm using. So you can do that with the command line, and you can also do that with the console. So we are going to take that in. So let's see some more things about containers. So let's see how containers can be used in a modern hybrid cloud or a multi-cloud architecture. So looking at the typical on-premise distributed system architecture, which is how business traditionally met their enterprise computing need before cloud computing. So before cloud computing also came, business was surviving. Maybe not as fast as this, but they were also surviving. And sometimes they use a case of distributed system. So keep going. And with distributed system, the distributed system works on the principle of maybe spreading the computing workloads over two or more network servers. Another way that distributed works are containers break these workloads. So with the advent of containers, it can help you like break these workloads into different microservices. And it here's an example of a typical on-premise architecture. System and workloads are housed on-premise. So when we say something is on-premise, that means something is in a company physical data center, or it's just them within the four walls of their building. That's an on-premise application. On high capacity servers running on the company network. So there are also a lot of steps required to upgrade an on-premise system. And if some of you have done maybe IT role before, you'd see how companies that host their servers in within their four walls, how they are always very anxious when the server goes down, or even when maybe the UPS that is powering the server room goes down or is not working, or people need to put it off at a particular time. They typically give you odd time to come for maintenance, maybe come in the midnight. And even still, that is still the midnight, the company still feels they are losing a lot of resources as our platform is not live at the moment, and they typically just want their service to run forever. So these are some of the things some of the troubles that an on-premise architecture can bring about. And the upgrade time could be anywhere from several months to 1 or more years. So, and it's often quite costly considering the fact that the useful lifespan of an average server is 3 to 5 years. So they typically like have to change maybe their Cisco server or any server they are using in a maximum of 3 to 5 years, which is not it's not really scalable and cost efficient compared to just using a public cloud. So what if you need more computing power now, not months from now? So, and also to even set up those servers, they are not like immediate. You have to set them up, you have to test, you have to see the connection between both of them, and setting it up typically takes days, even if not months, typically takes days. But with the cloud providers, all these things are already there already, and you can just spin them up at once. So what if your company wants to relocate some workloads to the cloud, but can't move the entire enterprise app from the on-premise network? So there's also, yeah, so these are just questions that you may want to ask. So if the company wants to still leave some things on-premise, I want to move some other things to the cloud, or if they want to use specialized products and services that are only available in the cloud, but they still want some of their infrastructure or some of their servers to be on-premise. So there's something called modern hybrid or multi-cloud architecture. So this typically like moves only some of the compute workloads to the cloud. You can only just lift what you want to lift to the cloud and leave the remaining one on-premise. And you can migrate this workload at your own pace. You choose how fast and how often you want to migrate your servers. You can quickly take advantage of the cloud flexibility, scalability, and lower computing costs. So with cloud also, you have some things to explore from, and you can add specialized servers to your compute resources, such as machine learning, content caching, data analysis, long-term storage, and IoT toolkit. So with the clouds have a whole lot of other added advantage I can give you. You can run your machine learning codes or machine learning applications. There's also an ability for content caching. So something like Redis or memory store. So content caching means just like every one of us has a cache on our phone that saves more of like save our progress on that app, and typically save us from coming to the lab, coming to the application every day and just logging in from beginning. When you typically download WhatsApp on your phone, you typically do all the settings that you want to do. But after doing that the first time, the cache service on your phone will be the one that would save all this temporary information and just serve them when you need them. So that's typically what cloud can also help you to do. And with content caching, it can also make information readily available to your customers and not them waiting for minutes before some information are getting loaded. There's long-term storage, there's data analysis, and there's also some Internet of Things computing resources toolkit that organizations tend to benefit from the cloud. So there's an hybrid and multi-cloud, and in an hybrid and multi-cloud, okay, so let's see. So with hybrid and multi-cloud, when you're having an hybrid setup, that means you are doing some things on premise, you are doing some in the cloud, or even if you are running a multi-cloud. Multi-cloud means using multiple cloud providers. Let's say I'm using AWS, I'm using GCP, I'm using Microsoft Azure, I'm using both, I'm using the three of them together, and I have different service on different cloud providers, but maybe some of them interconnect together and they are serving the same end users. So how can you manage them? So Google has a tool called Google Cloud Anthos, and Anthos is used to manage modern and multi-cloud distributed system and service management. So what is Anthos? So Anthos is an hybrid and multi-cloud solution. It's a framework that rests on Kubernetes and GKE on-premise. So it's more of like you're bringing Kubernetes and you're bringing the power of GKE to your on-prem server, and it provides a rich set of tools for monitoring and maintenance. That's it's Anthos. So Anthos, it provides the foundation for an architecture that's fully integrated and has centralized management to a central control plane that supports policy-based application lifecycle delivery across hybrid and multi-cloud environments. So Anthos can help you manage your multi-cloud or your hybrid architecture and bring some of the computing power or some of the monitoring power, some of the Kubernetes ability and containerized application that you typically enjoy in the cloud. You can bring it to your on-premise application. So taking a look at Kubernetes. So the Kubernetes engine is managed production-ready environments for deploying containerized application. It operates seamlessly with high availability and an SLA. So there's an SLA for Kubernetes, and the SLA is quite high. So SLA means service level agreements. So, and typically all these cloud providers, they have an SLA. That means they have a minimum amount of time that you can expect their service to go down, and they're typically like 5 minutes in a year. So the SLA is just like they expect that, oh, if you even have a downtime, it's like having a downtime for just 5 minutes in 365 days, and that's pretty very small. So they have an SLA of like 99.9%. Some of them even have 5 nines in SLA. So you can run certified Kubernetes in GKE, and that helps to ensure portability across clouds and on-premise. You can include auto node repair, auto upgrade, auto scaling, and you can also use regional clusters for high availability and multiple control planes and node storage replication across multiple zones. So when you have regional clusters, so typically your users in different regions connects to the closest region to them. They connect to the closest cluster in that particular region that's closest to them. And they're not just all traffic from different regions are not just coming to a cluster in the region. And looking at GKE on-prem, so it's like a turnkey production grade conformance version of Kubernetes with a best practice configuration preloaded. So this other side is like you're bringing the GKE functionality, the GKE capabilities, you're bringing it on-prem. So here are some of the things that you would also benefit. It provides an easy upgrade path to the latest Kubernetes release that have been validated and tested by a cloud provider, in this case, Google. It provides access to container services on Google Cloud, such as Cloud Build, container registries, and Cloud Audit Log. So you can also gain some of the advantages that you would gain normally when you have your GKE on-prem with Anthos. You can integrate with Istio, Knative, and Cloud Market solutions. You can also ensure a consistent Kubernetes versions and experience across the cloud and on-premise environments. So yeah, that's a few of the things or few of the reasons for bringing GKE on-prem. And when you have your GKE on-prem also, you can interact with with third-party integration from the cloud marketplace. So you have access to the cloud marketplace and see various services that you may like and just pay for them with the cloud marketplace. So, and You can also connect the on-prem to the cloud through cloud interconnect. So there are different ways to like connect your on-prem application to the cloud. You can use the VPN, you can use a dedicated interconnect, and you can use a partner interconnect. So all these are just ways how you can connect your on-prem data centers to the Google Cloud. And okay, Anthos Service Mesh and Istio open source service mesh takes all the guesswork out of managing and securing your microservices. So these service mesh layers communicate across the hybrid network using cloud interconnect to sync and pass data. So it saves you a lot of stress of managing and securing your microservice. Going so there's also a cloud login and cloud monitoring. So I've explained that before, the built-in login and monitoring solution for Google Cloud. And you can offer a fully managed login, metric collection, monitoring, dashboarding, and alerting that watches all sides of your hybrid and multi-cloud network. And it even typically help you to become more safe, and you know who have done a particular thing, who did a particular thing, and anytime there's an issue, you can just trace back to the latest change or to the latest changes, and you can revert those changes. It's an ideal solution for customers wanting a single, easy to configure, powerful cloud-based observability solution that also give you a single pane of glass dashboard. So with just one dashboard or multiple dashboards, you can monitor all your environment, and you can just monitor. You can even decide to. They are custom monitoring that you can just decide to monitor what only interests you. So anytime you know that there's a breach in that, it puts you on high alert. And so here are just some Anthos configuration management. And to read more about Anthos, you can check this link to read more about Anthos. So Anthos just typically helps to bring the power of Kubernetes to your on-premise data center, and you can have access to that in nearly an equivalent way to someone using Kubernetes on the cloud or using GKE on the cloud. So that's a little bit overview of Kubernetes on the cloud. So you can try to read more or try to watch the videos that are in this track so that you can get more understanding on what Kubernetes means and how it relates to one another. I think we should go over some of the quiz. Before that, anybody who has questions? Any questions? Yeah, so before I go further, so likewise, we'll be having on our class on Wednesday, we are going to be doing a cloud study jam. So the cloud study jam, in a sense that I will be doing that is I'm going to share a link. I'm going to share a lab link to everyone on the call on Wednesday. And when I share the lab link, I'm also going to grant you the token. They are going to be able to access this lab. So the lab will be quite simple, and it's just to be beginner friendly, because I don't want a case whereby some of us are not able to complete it, and we are now like having issues not getting the 30 days free credit. So the lab will be pretty simple and basic, and it's something that every one of us should just complete in real time. So this is just to remind you all that if you really need the 30 days free access, then come to the class on Wednesday. Yeah, so it's on Wednesday. It's on Wednesday that you'd have access to the link, and it's also on Wednesday that the token will be available. So then we'll give more information also on Wednesday regarding that. So I'll try to put it on the group also. Okay, let's go over some of the quiz here. So going over the quiz on GKE. Not this. That's the quiz. Okay, containers in the cloud. This means we take. Okay. So from our explanation, what is a Kubernetes pod? Yeah, so a Kubernetes pod group of nodes. No, a Kubernetes pod is not a group of nodes because there are multiple nodes. There are multiple nodes, and each node has their own pod. So a Kubernetes pod is not a group of nodes. A group of virtual machine, also not a group of virtual machine. A group of cluster, it's not a group of cluster. It's a cluster that even houses the nodes, and the nodes houses the pods. But a group of containers, yes. So a Kubernetes pod is a group of containers because it can be multiple containers in a pod. It can be multiple containers in a pod. And the next one, what is a Kubernetes cluster? A group of pods that manage the administration of a Kubernetes application. That's a Kubernetes cluster. It's a group. It's a group of pods. So there are multiple pods in a Kubernetes cluster, but it's not a group of pods that manage the administration of a Kubernetes application. A group of containers that provide high availability for application. A group of containers. No, it's not a group of containers. A group of machines where Kubernetes can schedule their workload. That's typically this third one. So Kubernetes pods are like Kubernetes clusters are like various machines that Kubernetes can schedule their workload. So you can schedule on this cluster, schedule on the other clusters. And in a cluster, there a cluster comprises of multiple nodes. And in each node has its own pods. And when you go inside those pods, you can have multiple containers in a pod. So it's a group of machines that scheduled workload. Where do the resources used to build Google Kubernetes engine cluster come from? Anyone can anyone go over this? I think we talked about this a bit. If you want to talk, you can just unmute your mic and go ahead. Mm, anyone? Where did the resources used to build Kubernetes engine cluster come from? It's not bare metal server because we never even talk about bare metal server. It's not cloud storage. Cloud storage is just for saving applications, it's for saving documents or saving anything. We mentioned that cloud storage is a blob. You can typically save any file format. You see App Engine. We mentioned App Engine, but we mentioned App Engine in another case and not really in where Google Kubernetes Engine cluster come from. When we mentioned GKE, we said GKE more like manages a group of complete engine virtual machines together to form in a cluster. So the resources that used to build a group Kubernetes in a cluster come from the complete engine. How do containers access an operating system? So the first one here is the shared container use a shared base operating system stored in the cloud storage bucket. So they can use a shared base operating system, but it can never be stored in a cloud storage bucket. Container is a shared base operating system stored in a shared runtime layer. So it's not a shared runtime layer. You mentioned that each of them has their own runtime layer for their service. Looking at this one, container uses a shared base operating system stored in a shared kernel layer. So this look more correct. We talk about kernel when we're talking about Kubernetes, and containers can use a shared base operating system that are stored in a shared kernel layer. Whereby we mentioned that they can share a similar resource and they can share the same storage options, and each of them are still very much isolated. So it's in a shared kernel layer. Each container has its own instance of an operating system, so it's not every time. Number 5, Anthos provides a rich set of tools for monitoring and maintaining the consistency of your application across each of the following locations. Anyone to go over this Anthos one? Probably the last thing we talked about. If you want to talk, just feel free to unmute yourself and go for it. Anybody?
I think it's the second one.
Okay, so what's the second one? Okay. Anthos hosted application hosted on premise in the cloud or in multi-cloud. Yes, yes. So it helps for on-premise in the cloud and also multi-cloud. If you take a look at this first one, application hosted with multiple cloud provider only. So that's not correct. There's an on-premise in a single cloud and also multi-cloud. So this is correct. Application hosted on one cloud provider only. So no. So when it has multiple cloud or multi-cloud, so that means different cloud provider. Application hosted on premise only. So this is too limiting. For question C, state two reasons for using containers to deploy application. So the two reasons, one of this is allocating resources in which to run containers is not necessary. So this is not two reasons for using containers to deploy application. This is not a reason. The second one, migrating workload is simpler. Yeah, so typically migrating workload is simpler. As you said, it's like a lightweight application. So you to choose this. It provides tight coupling between application and operating system. Yeah, so we said there, there's a we said there's a case of microservices. So it does not like provide tight coupling. It even helps you to be able to make changes as much as possible because things are isolated. So there's no real tight coupling. This is even like opposite of what containers does. The containers try to keep a microservice architecture whereby things are not like in micro level and not so things are not like fixed. So there are different movable parts in a container. A lot of movable parts in a container. This one it creates consistency across development, testing, and production environment. Yeah, so this is correct. How do you keep your Kubernetes version updated in Go Kubernetes engine? You want to go over that? The first one, you need to stop your cluster and manually update the Kubernetes version in your cluster. So this is wrong. We said Google Kubernetes Engine is a managed deployment of Kubernetes. So manage in the sense that most of the resource configuration are done for you automatically. You cannot update a running cluster. You need to create a copy of your cluster with the updated Kubernetes version. This is also wrong. So all these things are not necessary. You cannot update a running cluster. You can do that. You don't need to create a copy of the cluster with the Kubernetes version. So there, when we talk about rolling out updates, so you can roll out updates while one of them is still functioning, and when the other one is good to go, you can depreciate the other one. So you are required to set up a cron job to periodically check the Kubernetes version in your cluster. So you don't need that. You don't need to always be checking your Kubernetes version for anything. If you're even using a GKE, if you're using GKE, so GKE manages the updates and a whole lot of things for you, and you don't need to periodically check anything. So that leaves us to just the last one. The Google Kubernetes engine team periodically perform automatically upgrade of your cluster to newer stable version. So this is correct. So a lot of the updates that are required, a lot of the security patches are automatically done by the Google Cloud team. Yeah, so it's going to save this, and here we are. So for the Kubernetes, you can I linked a video here that we can check. So the video is not it's not the same thing as the lab, but it's quite similar. This is also like getting started with GKE. And when you go over it, you also see how GKE works. And for this cloud one, also under application, I linked the video there and automating the deployment of infrastructure using Terraform. There's also a video on it. So I think we may not need to go over those videos in much details on the call. But before we go off, I think we should go over the quiz under application in the cloud before I free you all. So I'm just going to take this. Or anyone who has any question regarding the containers in the cloud before we move to the next topic. Okay, fine. So, application in the cloud. Which Google Cloud services should you choose to perform business analytics and billing on a customer-facing API? So, for us, for you all to follow this thing very well, so you all should have at least even gone over all these videos. At the very least, if you were not even able to go to the PDF, should have watched these videos. The videos are typically not long, maximum of 10 to 11 minutes. I'm very sure some of all these are even 5 minutes or less. So, which Google Cloud service should you choose to perform business analytics and billing on a customer-facing API? So, if you watch the video, you'll see that they talked about RPG. And RPG helps you to like manage a whole lot of APIs. RPG is the tool that helps you to manage a lot of application programming interface calls or APIs that you need on the cloud, on Google Cloud. So with RPG Edge, it helps you to do a lot of management, and you don't need to start typically managing or taking a look at each API to see how they are doing. So that would go to RPG Edge. For this, App Engine is best suited to the deploy to the development and hosting of which type of application. So App Engine is ideal for web application. App Engine has always been very ideal for web application. So looking at this one, application that requires full control of the hardware they are running on. So no, application running. So if this is the case, this will probably be something that a virtual machine will be the best use of. A long running batch processing application, and App Engine requires at least one instance running at all times. So App Engine does not even application that requires at least one instance running at a time. So that's not true, because with application with App Engine, you can even scale to zero, whereby you are not spending anything. So if this is saying the application that requires at least one instance, it's not it's not true. And those are typically a good fit for a web application. It's only when people need them or when people are maybe using them that it should really be running. When people are not really using them, it shouldn't be running so that you don't waste resources or computing power. Select the manage compute platform that lets you run stateless containers through web request or pops up request or pops up events. So for stateless container, when if you look at all the if you look at this thing, when they say stateless containers through web request or even pops up event. So this is more of like talking about a serverless architecture. Serverless in the sense that it's something that you don't need to provision servers, and your servers are provisioned for you automatically. And that's typically also what makes it stateless, because it can the state that it was before does not really matter at this particular time. It's not like it's keeping state or keeping anything that is happening, and you can just run it through web request or pops up events. So pops up is a publishing and subscribing and messaging platform on Google Cloud that can respond to events that are happening. So when an event happens, the pops up can publish the event and the subscriber can read from the event. So this would more go to Cloud One. Cloud One is serverless. Cloud endpoints. The cloud endpoint is different from all this. The cloud endpoint typically works from maybe API. RPG Edge is just an API managing platform. And for cloud source repository, so this is just like a GitHub that you can keep the repositories of your code that are happening. So this is Cloud One. Which statements are true about App Engine? App Engine manages the hardware and networking infrastructure required to run your code. Is that true? App Engine manages the
Yes, it
hardware,
is.
and so can you explain why you think it's true?
Um, because when you're using App Engine, you're not worried about the hardware most of the time.
So with App Engine, you typically maybe just bring in the code you want to run, and it gets run. So it manages the hardware and the network infrastructure. Yeah, so that's correct. Okay, thanks for that. App Engine requires you to supply or code your own application load balancing and login services. This is not necessary. App Engine does all this for you. Developers who write for App Engine do not need to code their application in any particular way to use the service. Then you still typically need to code your application in a way that you want to use the service. So you still don't typically need to, yeah, and it's even the code that even run those applications that you are bringing. So it's still code dependent also. The daily billing of one App Engine application can drop to zero. So this is true because we said it's ideal for web application. So if the web application is not up, the billing can go as low as zero and you'll not be charged anything. So this is very true about App Engine. App Engine charges you based on the resources you pre-allocate instead of the resources you use. No, no. And typically in App Engine, you do not necessarily need to even pre-allocate resources. So it's a managed platform and you are not really pre-allocating any resources. And number five, what are the advantages of using App Engine flexible environment instead of its standard environment? So there are two types of App Engine environment. There's the flexible and the standard. So for those who went over the course slide, I think we should be able to get some of these. You can SSH to connect to the virtual machines on which your application run. Yeah, so this is true for flexible environment. You can SSH into the virtual machines for sure. You can install third-party binaries. So there's also ability to install third-party binaries on flexible environment. You can connect to third parties and install their necessary configuration stuff. The application can execute code in the background threads. So this may actually be true, but it's not specific to flexible alone. It can also work for standard. The application can write to a local disk, so this is correct. With the flexible, it can write to a local disk. And Google provides automatic in-place security patches. So this works for flexible and works for standard. It's not only for flexible, it works for both of them. So these are the three that I feel it's that they are only like explicit to flexible alone. Cloud One can only pull images for this. Anyone to go? Anyone wants to talk about?
The artifact registry.
Yeah, so the artifact registry are just like where we save our image, where we save our images. Our container images are saved on the artifact registry, and when we need them, we can pull them from there. So this is correct. Self-hosted registries. I'm not sure about this if you can connect the self-hosted registry, but Docker Hub is just from Docker containers that you have, and GitHub is just the normal code versioning software that we have. So artifact registry is more correct because it's on Google Cloud. It's on Google Cloud. All these are typically not on Google Cloud, the other one. So this is on Google Cloud and you can connect to it. You can connect to it from Cloud One. So also going to submit this and we also get everything here. So that's more often than not what we are going to go over for today. And this developing and deploying in the cloud with Terraform, it's very interesting. It's very interesting. So, and it's also a lab that you'd even check and you'd be happy with what you are doing. A whole lot of the things that we were configuring manually, yeah. So you can just write configuration files for them on Terraform and they get created. So Terraform helps us to automate creation of infrastructure, automate creation of services. So when you take a look at this, I think you'd also appreciate what cloud can do and how you can leverage on cloud more. So yes, so please, every one of us should try to make sure we show up on Wednesday and we are on the call so that we can all complete the lab that's required and get access to the 30 days free access that we've talked about. So And like I said, try as much as possible to come with your system. So the lab, it's not a complex lab. I probably pick the simplest of it all for us to do. So it's not complex. And when you do it and when you complete the lab, you you get access to the 30 days subscription. And if you complete the quest after that day, you can also get another 3 months subscription also they're going to give to you. So making like 2 months. And that's probably what's over. So I think the subscription for a month is $29 or $27. So if you add that together, so that's a whole lot. And that can help you to try a whole lot of services that you want to do, and a lot of services that you want to, a lot of labs that you just want to go over and see what we can do. So as we also round up the call, I'm also going to like bring out parts for each and every one of us, depending on our area of interest. So if you are someone who's excited about machine learning, I'm going to point you through some machine learning services that would help you, though, that you can keep studying along the line. If you are someone who's excited about maybe data analysis, data engineering, data architecture, something like that, we'd also point you to resources on that part. And if you are just something that if you are just someone who's excited about maybe web applications, how to manage web servers, something like that, would also point you towards resources that would help you in that range, because the cloud is very big and you typically do not need to be you would probably not even be able to be sound in everything, sound in machine learning, sound in DevOps part, sound in the operation part, sound in the security part, sound in the networking part. So it's a whole lot of services, and you can pick your area of specialization and pursue more depth in that particular category. So thanks very much, you guys, for staying true. And is there any question we have for now? Any question? I'm going to I'm going to set up the assignment against next week, against Wednesday. So the assignment I will typically give you all against Wednesday is just to read up on developing and deploying in the cloud. So we can even typically finish everything against Friday. Okay, so let's just stop here for tomorrow, for against next tomorrow, so that for those of you who have not watched those videos, should go and watch it. And if you also want to complete it before the class, feel free to complete it. Feel free to complete all these things. So when we eventually get the 30 days free credit, then you all will be able to take this lab by yourself. And part of the requirements for getting certification would be showing this skill badge. So this skill badge that I have here for completing this course, experience it's coming. So this skill badge that I have for finishing this course will be part of the requirements that would enable you get the certificate at the end of this course. And I also want us to maybe also complete another course after this. So this is just the Google Cloud Fundamental Core Infrastructure. If you check the course content that I shared with you, there are some other courses that I highlighted there that are also important that we can go over. But as much as we are not very fast, I also want us to also understand this section very well, so that even when we continue the learning on our own after the bootcamp in a self-paced manner, we have like a good foundation to build upon it. Yeah. So, any question? I'll send the assignment to the group today in a bit. Any question? You are. Okay. Any complaint? Any clarification? Any thoughts? Yes. Okay, that's fine. So if you have any question, feel free to reach out to me on the group, or even reach out to your colleagues. I think some people are also getting very much comfortable with some of the things that we've been discussing and some of the services on the cloud. So you can throw an open question on the group and people can also share their thoughts about it or what they think about those particular questions. And so community learning has it helps a whole lot. And when you discuss, you get to see different perspective and you even get to understand why something is correct, why something is not correct. So you also try to interact closely among yourself and learn as much as possible. So see you all on Wednesday. Make sure you show up on Wednesday and if possible, come with your laptop. I'm not very sure if you'll be able to complete that lab on your phone, but try to come with your laptop and let's keep going. Yeah, so thanks very much for staying through. Bye guys. Yeah, attendance link. Okay, I'm going to share the attendance link in a bit. Just wait a little bit. Pull up the attendance link now as much as possible because I also know that some of us may join and not fill the attendance link. So I would also prioritize having the cloud skill, having the digital badge to give certification at the end. I'll pull up the attendance link in a bit. Okay. I'm sharing it to the chat section now. The attendance link is typical, it's the same thing for every week. So you can save it and just come on there and fill it in. I also take screenshots. So if you're not coming and I just fill in the attendance link, I'll probably know along the line. Yeah, so fill the attendance link and bye guys. If you have any question, please feel free to reach out to me. I'm happy to answer you. Hi, everyone.
Bye, sir.
Yeah, bye.